Well, good morning, everybody. And I also welcome our guests from Lille. I hope you had a pleasant drive this morning. And we're going to start this morning here with this defense. Hereby, I open officially the academic ceremony in which Mr. Guillaume Carey will defend the this academic thesis entitled Imaging Anxiety in Parkinson's Disease. May I invite you to present a summary of your study and the conclusions of your study in the next 15 minutes. And I'd like to give you the word.
Thank you. Highly esteemed Prorector, highly esteemed and esteemed promotion team, dear colleagues, family and friends, I'm honored to defend my PhD work entitled Imaging Anxiety in Parkinson's Disease. Parkinson's disease is a brain disorder due to a progressive loss of nerve cells that produce dopamine. Dopamine is a chemical in the brain that acts like an essential messenger for the regulation of motivation, movement, cognition, and emotion. Parkinson's disease is characterized by non-motor symptoms, such as slowness, stiffness, tremor, and walking difficulties, and also by non-motor symptoms, like affective disorders, sleep disturbances, constipation, bladder dysfunction, or cognitive impairments. Among these non-motor symptoms, anxiety is frequent, with 31% of patients experiencing it in the course of the disease. This is higher than in a healthy population or in other chronic diseases. It has a negative impact on Parkinson's disease symptoms and reduced quality of life of patients. According to an international survey, reducing stress and anxiety in Parkinson's disease is the second research priority for patients and caregivers after reducing walking difficulties. Before going to anxiety in Parkinson's disease, let's take a few minutes to specify what is fear and what is anxiety. Fear is an emotion generated by threatening situations, while anxiety is the physiological and the psychological state in reaction to fear. When anxiety becomes disproportionate, it is pathological, and we speak about anxiety disorders. In the brain, different pathways exist to regulate fear and anxiety and can be altered in anxiety disorders. In Parkinson's disease, patients can present different forms of anxiety disorders. The most frequent is the generalized anxiety disorder, followed by phobia and also panic attack. However, many patients have multiple anxiety disorders and also anxiety due to the other symptoms of Parkinson's disease. For example, fear of falling or anxiety associated with motor symptoms fluctuations. Even if anxiety in Parkinson's disease is well described, its management is very challenging. Currently, only few pharmacological treatments are used to treat it, such as dopaminergic treatments, anxiolytics, or antidepressants, but they have limited evidence of effectiveness and raise some concerns about side effects and complications. Therefore, non-pharmacological intervention should also be considered, such as physical activity, mindfulness, acupuncture, or psychotherapy like cognitive behavioral therapy. Thus, many questions still surround anxiety in Parkinson's disease. What are the mechanisms of anxiety in Parkinson's disease? Why does it occur so often in the course of the disease? How to treat it? Or can we predict its course? In this context, the objectives of this PhD work were firstly to understand the mechanisms of anxiety in Parkinson's disease, secondly, to understand how psychotherapy for anxiety works, and finally, to validate our previous findings using high-resolution brain imaging. To answer these questions, we use brain magnetic resonance imaging, MRI. MRI uses a magnetic field to capture signals from hydrogen atoms present in the body's tissues. These atoms react to the field and emit signals, which are then converted into images. This enables to see the brain structures in detail without using radiation. MRI can help to analyze different structural characteristics of the brain. The bodies of the nerve cells are located in the brain cortex. As we can see on the left side of the slide, analyzing reduction of its thickness enables to identify dying cells and brain atrophy. The deep structures of the brain are involved in several pathways. Studying their volume, shape, or texture enables to identify local nerve cells loss. And finally, on the right side of the slide, we can see that MRI can identify changes of the anatomical connections between these cortical or region structures, or deep structures. MRI can also identify changes in the brain activity using functional MRI. It measures changes in blood oxygen levels in the brain. The active areas of the brain consume more oxygen, producing a higher signal on the MRI, which makes it possible to measure the brain functional activity. Now I present the results and the discussion of the studies included in this PhD work. In the brain, the amygdala is one of the deep structures of the limbic system that is associated with behavior, emotion, and cognition regulation. It has a central role in the regulation of fear and anxiety, with its numerous connections with the other brain structures. Our research project started with the study of Rindt and collaborators stated that a smaller amygdala could be associated with anxiety in Parkinson's disease. Due to these numerous connections, amygdala can be considered as a central hub of a pathway involved in processing and regulation of fear called the fear circuit. When we experience a fearful stimulus, this circuit is activated in order to cope with the threatening situation. In anxiety disorders, this fear circuit is disproportionately activated. Otherwise, the amygdala is also connected to the striatum, a part of another circuit called the limbic circuit, activated by dopamine. It is involved in regulation of behavior and cognitive control of emotion. This circuit is also a part of a well-known brain pathway connecting the cortex to the striatum, then to the thalamus, and back to the cortex. In Parkinson's disease, the lack of dopamine, among other messengers, reduces the activation of this limbic circuit, altering the cognitive control of emotion. Regarding our first research objective, the results of our MRI studies confirm that anxiety in Parkinson's disease is associated with structural alterations with these two circuits, such as reduction of thickness in the brain cortex or local nerve cells loss in the amygdala. We also found changes of anatomical connections within the fear circuit on the left side of the slide and within the limbic circuit, as we can see on the right side. Our results also confirmed changes in brain activity within these circuits, especially within the amygdala and in the brain cortex. Therefore, we concluded that anxiety in Parkinson's disease is associated with alterations within the limbic circuit and within the fear circuit. Moreover, the limbic circuit will be underactivated, resulting from the reduction of dopamine in Parkinson's disease, causing a lower cognitive control on emotion and behavior, while the fear circuit will be overactivated, provoking high fear reactions even for a slight stimulus. This corresponds to an imbalance between these two circuits, leading to anxiety in Parkinson's disease. Now, regarding our second research objective, we mentioned earlier that management of anxiety in Parkinson's disease can be very, very challenging. Non-pharmacological interventions must be considered, and especially psychotherapy like cognitive behavioral therapy. This therapy provides a toolbox of different methods to mediate thoughts and cognition in order to modify behavior and emotions. This has been validated as an effective treatment to reduce anxiety in Parkinson's disease. In this context, we aim to identify the mechanisms by which cognitive behavioral therapy could reduce anxiety using functional MRI. Our results suggest that improvement of anxiety symptoms after the psychotherapy is associated with changes in the brain activity within the brain cortex and deep structures on the left side of the slide, and also within different brain pathways on the right side. With these results, we provided an hypothesis of cognitive behavioral therapy mechanisms to reduce anxiety in Parkinson's disease. This psychotherapy would restore the balance between these two circuits by increasing the activity of the limbic circuit, providing a better cognitive control over the fear circuit, resulting in an improvement of anxiety symptoms. Above our findings, some questions remain. The two imbalanced circuits involve overlapping structures, such as the nuclei secreting dopamine and other messengers in the midbrain. The role of these structures is still unclear in anxiety in Parkinson's disease and need to be studied. Moreover, early identification of anxiety in Parkinson's disease would enable to develop personalized treatment strategies and preventive care. Therefore, identification of risk factor and imaging or biological markers of anxiety in Parkinson's disease is needed. In order to answer these questions and regarding our third objective, we are currently working with the TRACK-PD study, a longitudinal study including Parkinson's disease patients and healthy controls, assessed at baseline, 2-year follow-up, and 4-year follow-up, with a clinical, cognitive, and neuropsychiatric assessment and a high-resolution 7 Tesla brain MRI. So to conclude, the take-home message of this PhD work is firstly that anxiety in Parkinson's disease results from an imbalance between the fear circuit and the limbic circuit. Secondly, cognitive behavioral therapy restores the balance between these two circuits by increasing the cognitive control over the fear circuit. And finally, further studies are in progress with TRACK-PD study. At present, we are working on cortical thickness, deep structures features, and functional MRI analysis using these data. So this is a brief summary of my work during these last years. Thank you for your attention, and I now give the word back to the prorector.
Thank you very much, Mr. Candidate, for your very interesting presentation, well illustrated, and I think your presentation will result in quite a lot of discussion, which we're going to start now. But before we're going to start, I'm going to introduce the promotion team who sits here in front of me. And I'm going to introduce Dr. Kuijf on the right side over there. He is involved as an affiliated as neurologist at our university. Then we have from Lille, Professor Dujardin, welcome. She is chair of the Department of Neurophysiology at the University of Lille, or should I say Lille 2, I'm not quite sure about this, in France. And of course, the first promoter is Professor Leentjes, and he is professor in neuropsychiatry with a focus on psychopathology of movement disorders, quite a long title. They have guided the candidate in the last 4 years to reach this point that he's going to defend his thesis. For the audience, we have 6 opponents who are going to discuss with the candidate, and I'd like to start with Professor Linden. Professor Linden was the chair of the assessment committee, and he is involved as professor in translational neuroscience at our university, and I'd like to give him the opportunity to discuss with you as first opponent. Professor Linden.
Dear candidate, congratulations on this very interesting work and also the excellent and very clear presentation. Also congratulations to your international promotion team, and it's great to see all these efforts coming out of the Euron collaboration that you're presenting here. The topic is of great interest, of course, clinically, neurobiologically, and I would like to start with your very interesting statement 2, and I would like to ask your paranymph to read statement 2 for us.
In Parkinson's disease, dopaminergic depletion reduces the activity of the limbic anxiety circuits. This is chapter 3.
Thank you. And indeed, this refers to chapter 3, and I think particularly to the figure 1 on page 79. I don't know whether you have a thesis at hand, or, I mean, I'm sure you know your thesis and the figures very well. Can you just explain, I mean, you touched on this in your presentation as well, the differentiation you're making between a cortical limbic circuit, or limbic basal ganglia circuit, and the sort of fear circuit. So just because I think there's sort of an imbalance between these two, and there's overlap. So perhaps you can just walk us through exactly what is overactivated in your model and what is underactivated.
In this highly esteemed opponent, thank you for your question. And yes, in this figure, I try to construct these two circuits. And first of all, we mentioned in this study that maybe it's kind of artificial, of course, but yes, the first step of this work was to construct on this kind of figure these two circuits. And maybe it was a first version, but using this review, this systematic review, we found that a lot of connections of the fear circuit, and especially the amygdala with the prefrontal cortex, were really overactivated. And it's interesting because this connection between amygdala and prefrontal cortex, and especially the orbitofrontal cortex, can act like a cognitive filter of emotion, and being overactivated maybe will provide a higher activation also of the amygdala, and provide a higher fear reaction for the slighter stimuli. And I think finally also the connections within the anterior cingulate and the striatum were in this review also overactivated. But this specific connection can be also discussed, because in further studies we find the opposites.
Well, let's stay on what you're describing here. I think it's very interesting. So the basic idea would be there's altered functional connectivity, and then that, as you're seeing on MRI, and that may correspond to an altered and perhaps increased input in some way into the striatum, and that again may correspond to some disinhibition from higher cortical, so-called higher cortical areas that you're showing there with the deactivation with the dotted blue lines. So I think that's interesting, and this is your imbalance. You have the potentially reduced cognitive control, increased input in the striatum, into the striatum. How then can you and then you have the striatum line to the amygdala, for example, where you see the overactivation of the fear circuit. But at input level, if you have a global input into the striatum, at that level, and certainly your model doesn't differentiate between the input from the striatum into the limbic fear circuit, into downstream basal ganglia circuits, and ultimately also into the different subdivisions of the basal ganglia. So how can you differentiate this? Because surely you're seeing differential effects on motor and non-motor symptoms from this circuit.
Yes, it's not a really thing to do, because differentiating these different parts of the basal ganglia can be challenging using imaging methods.
And may I link to this? Do you believe in the so-called tripartite model of the basal ganglia?
Do you, excuse me?
Do you believe in the tripartite model of the basal ganglia, in the motor, limbic, and associative subdivision?
Could you rephrase? Excuse me.
I mean, this the idea that the basal ganglia is sort of the striatal loop from striatum to thalamus, and is really not a pure motor system. I think that's becoming clear from your work as well. But you can identify separate pathways that are sort of separate subdivisions of the subthalamic nucleus, for example. A lot of DBS work, I think, has related to this, that you really have different pathways within the basal ganglia related to affective, anatomically distinct. And if so, would you be able to differentiate them with your imaging methods?
I think that using 7 Tesla MRI, yes, would be interesting to subdivide these 3 circuits. And
yes, because I think you're getting there in another chapter of your thesis.
I've done that using for thalamic subnucleus. I think it might be possible also for subthalamic nuclei, substantia nigra also, and of course it's something I'm working on right now using 7 Tesla MRI, and I think DTI also may be interesting too.
And indeed, so in chapter 7 you're looking at subdivision of the thalamus, which of course then related to the potential output of the basic ganglia circuit. And could you also then link, and that's anatomical work at the moment, I mean in terms of structural anatomy, size of nuclei essentially, can you link this with connectivity?
Not yet.
Potentially.
Potentially, yes. I'm working on this kind of analysis right now, and it's totally possible. And the high resolution of the 7 Tesla MRI on TrackPD study will enable to do this kind of analysis with this really high resolution, and I can really see the difference when I was working on 3 Tesla MRI and now I'm working on 7 Tesla MRI. The resolutions are really different, and this kind of analysis is also possible. And if I want to go further, it's also possible to include other structures than just subthalamic nuclei, because right now I'm also working on locus ceruleus, subcerulus complex. I'm trying to work on ventral tegmental area, and also the subdivision of substantia nigra, it's possible, and maybe Raphe nuclei. So,
and just a final question related to this, you're obviously a clinician, so you've seen many patients with Parkinson's disease. Would you say, and we're talking about distinct pathways, would you say that the motor deficits, the motor symptoms and anxiety are sort of dissociated from each other? That
yes, it is. Anxiety is really associated with motor symptoms and other non-motor symptoms. I think when we have patients with Parkinson, suffering from Parkinson's disease, you have to take all these symptoms. I used to explain to the students and also to the patients that a Parkinson's disease patient have between 3 and 7 complaints during a visit. And our goal is to identify the first, the second, and eventually the third complaints, and try to fix these 3 first complaints. And then it will be improved, and the patient will get improved. So,
very clear answers. I think my time is up, and I have to give the word back to the pro-rector. Thank you.
Thank you very much. The opposition indeed will swiftly proceed with Professor Jardy. He is also a member of your assessment committee and chair of the Department of Child and Adolescent Psychiatry at Leeds University, and I'd like you to give you the word.
Thank you very much, Mr. Pro-Rector. Mr. Candidate, first of all, I would like to thank you for a nice and complete presentation of your work, which was very well adapted to a general audience, despite the high level of expertise. And my first question is a general question. So you describe a lot of different MRI metrics in your work, so cortical thickness, functional connectograms, structural connectivity. And my question is related to the field of precision medicine and the quest of biomarkers, which is crucial in it. And so could you start by reminding us what are the criteria to define such marker? And if you think that some of your work, some of your results on anxiety in Parkinson's disease could fit with this criteria, and what could be the next step toward this endeavor?
Highly esteemed opponent, thank you for the question. And the topic of biomarkers, and especially in Parkinson's disease, is really interesting. So the exact definition of biomarker is not exactly in my mind, to be honest, but as I can say about biomarkers, it's something that have to be physical marker, I mean biological, for example, or imaging measure from patients, and that could help to identify a disease or progression of a disease, or the onset or the progression of the disease, but as a personalized level. I know one subject level and not the scale of a group. So that's the most challenging part of definition of biomarkers, because it's not because a biomarker is interesting for groups that is also interesting for one subject. And I think it's really the big thing of biomarkers. And in my findings, it's not enough to talk about biomarkers. Because of my previous answer, I just worked on groups, anxious people and without anxiety, and even healthy controls patients. So it's not enough to define it as biomarkers, but it's maybe promising to use imaging data such as DTI or functional MRI as biomarker. But I didn't work on an iron charge, for example, or neuromelanin sequences that can be, and we know that can be really interesting imaging biomarkers. And finally, the third part of my answer is that only using imaging biomarkers is not sufficient. I also talked about biological biomarkers, and we can think about synuclein in CSF or in blood, and maybe in skin in the next years. And also genetics as biomarkers are really interesting. So we won't, or we cannot consider biomarker just as one thing, but several measures, several metrics that putting them together can help to predict onset or progression of a disease.
Thank you for your reply. Yes, I agree with the importance of moving towards a multimodal approach. I was mainly asking the question because some of the MRI results you're presenting regarding, for instance, functional connectivity, we know that it's sometimes very difficult to have some good test-retest reliability with these markers, and so to move towards the use of biomarker, we still need to demonstrate that, and I think it's very important, especially, and it leads to my second question regarding the use for therapeutic purposes. So you presented in chapter 6, you explored some therapeutic interventions for anxiety disorders in Parkinson's disease, and you evidenced changes in functional connectivity with anxiety scores after CBT. And I wanted to ask you if you think we could also use, so you present some pre and post changes in this study, and I wanted if you could detail a bit how we could also use MRI to predict response to CBT, because CBT is a very time-consuming approach, so it's better if we could identify responsive patients at first. So if you have any ideas about that, thank you.
So how I can use these results in clinical, you mean? Or?
These results or functional connectivity yes. Measures in general.
Okay, I think that firstly, I did not find another study doing this kind of analysis in anxiety in Parkinson's disease and CBT. So first of all, we have to prove and to validate these findings with other similar studies. And then I think we can use these results in two ways. First of all, in CBT, after CBT, you have good and bad responders, and maybe there is something that we can do with that. I mean, we can maybe find a region that we could target for specific treatments and non-pharmacological treatments. There is a recent systematic review that highlights the different non-pharmacologic treatments in depression and anxiety in Parkinson's disease. And they referred to the repeated transcranial stimulation using a magnetic stimulation or current stimulation. But the first challenge is to find a good target. And using this kind of findings could help us to find a target, maybe to combine CBT with another non-pharmacological treatment, such as RTMS. It's just an idea, but it's maybe a first possibility to use these findings. And another point of my answer will be maybe functional MRI in general could be used for neurofeedback, for example, using fMRI or EEG. It has been proved to be effective to reduce psychiatric symptoms in not healthy but general population, non-Parkinson's disease population. It is also studied in Parkinson's disease, and maybe using this kind of functional MRI techniques, methods, and neurofeedback could be helpful also to reduce anxiety in Parkinson's disease. I'm not an expert.
I still have time? No. Thank you for your answers.
Sorry, I apologize. We have to continue. So we have to continue because we still have 4 more opponents. And I would like to give the words to Professor De Bie. He was also a member of your assessment committee, and he's involved as chair of the Department of Neurology of the Amsterdam University Medical Center. Thank you for coming this morning, and I'd like to give you the word.
Thank you very much, Mr. Pro-Rector. Dear Mr. Candidate, I'm happy to share with you some thoughts on your PhD, but first I want to congratulate you with all the work and your team. And my questions will mainly be on chapter 6. And we did some ancillary study on this randomized controlled trial. And in the ancillary study, 9 patients were excluded because they had fear or anxiety or claustrophobia, it's maybe something different, for the MRI scan. Mm-hmm. And I just wondered if you could give some thoughts of how this could have influenced or biased your findings.
Highly esteemed opponent, thank you for this question. And yes, it was first a challenging question because including claustrophobic patients in an MRI study it can be discussed. But as it was also a randomized clinical trial, at first those patients were also important to be treated and to be studied. But yes, I think it's a limitation of this study because it could have influenced some of the results because we miss this part of anxiety, this part of claustrophobia or fear of something. And we know that this kind of anxiety can also be associated with Parkinson's disease. For example, I mentioned fear of falling or fear of symptoms. And we can imagine that in those 9 patients, maybe they are not really claustrophobic patients, but some of them have the fear to have motor symptoms during the session, the MRI session. So yes, maybe we missed some parts of the findings because of this limitation. But we also compared the 2 groups, the clinical monitoring only group and the treated group. There was no difference. There were similar patients with an efficiency on the PAS score of the CBT. So finally, this limitation might be a little one for me, as it was the first study of this kind of with this kind of objective.
There were in both groups equally. Right? So, but the MRI is something which can give you fear. We agree on this then. And then it's about your conclusion of all these findings, because I understood that you didn't see much change in the fear circuit, but more in the limbic system. And the limbic system is anxiety. So the conclusion one of the conclusions is that CBT can restore the imbalance between PD-related anxiety circuits and thus reinforce cognitive control of emotional processing, leading to improvement of anxiety symptoms in PD patients. So could it be that the patients with CBT just have less anxiety in the MRI scan, and that you're only measuring anxiety and not something about imbalance or functional restoration of the treatment? Because it looks to me that if this cognitive treatment is very complicated, there's a lot happening in the brain.
Of course.
Then you're just measuring the outcome is anxiety.
You mean imagine something to... I did not think about it yet, but we can maybe imagine some functional task maybe to increase the functional differences between these two groups, for example. But it can be also challenging because they are anxious, and it can also worsen anxiety. But I think you're right. It's sometimes difficult to conclude if we are looking at differences because of CBT or just because of anxiety. That's why we used also a linear multimodal approach to also have the anxiety score at baseline and not just to see anxiety at post-intervention. So it's a way to adjust the results. But imagine a task to complete this study. It's an interesting thought. I don't know yet which kind of task.
I think it's very difficult to get around it. So, but one more question. So it's more basic about the corrections of multiple testing you did, of 20 by 20 and 113 by 113. So there are a lot of things you're comparing, and I assume if you compare 20 by 20 matrix, it's about 200 tests. So then I looked in figure 2, and then I saw an uncorrected p-value of 0.0014, and then the FDR of 0.027, so I assume that is multiplied by 20. And then you do 200 tests. So I think, is that really enough to... So how does it work in fMRI research?
It's not divided by the number of comparison as we can do in Bonferroni correction. Yeah. It's family FDR correction. So I can remember the formula because it's automatically imputed in my tables. But it's easier to use FDR correction than Bonferroni correction, and it's a way to correct multiple comparison in imaging. It's implemented in my own pipelines, but also in imaging softwares. Like I use the software Con Toolbox. It's also implemented in that, and it's really sometimes difficult because we have a lot of uncorrected nice results, and after the correction there is few results, but that's how is research. So
okay, thank you. I'm happy to give the word back to the pro-rector.
Thank you very much. Then the opposition will be continued by Dr. Rutten She was also a member of your assessment committee, and she is involved as psychiatrist at the Amsterdam University Medical Center. And also I'd like to welcome here in Maastricht, and I give you the word.
Thank you. Dear candidate, first I wanted to congratulate you and your promoters, your co-promoter, and of course your family and loved ones on your great thesis and your great lecture. I'm always very excited when research on anxiety and Parkinson's disease comes out because it's a very difficult topic, and also in clinical care it's one of the things that is most difficult to deal with. And we both know that treatment options for Parkinson's disease are very limited at the time, so everything that gives us new directions for new treatments is very welcome. However, for now we still have very limited options, so I would like to invite you to come to my daily struggle and follow me on this fictional consultation today. We are going to see a patient in my clinic, let's call her Mrs. Janssen, who is referred due to anxiety related to Parkinson's disease. She is coming in with her husband, the strong silent type, and her son. And you see this lovely old lady who tells you about her anxiety. She tells that she worries about everything. She can lie awake all night worrying about what might go wrong next day. If she worries too much, she can get a panic attack, so it's pretty severe. And of course you did the research, so you recommend her CBT. And then she says, well, dear, that's very lovely, but I don't think that will work. I have Parkinson's disease, my brain is broken, so how is chatting with a lovely psychologist or psychiatrist going to help me with that? And I was wondering how you would use the results of your thesis to convince her to give it a try in just a couple of sentences.
Esteemed opponent, thank you. It's a really interesting clinical question, and it already happens in the past with patients. And yes, your question first of all highlights something is the accessibility also of the CBT, the psychotherapy. And what I would say to these patients, first I will re-explain the disease. Because with my experience, a lot of patients maybe have lack of knowledge about the disease. And sometimes if they think that anxiety or other non-motor symptoms are not linked to Parkinson's disease, for them it's not really logical to include these symptoms in the disease. So first of all, patient education, I think we can say that is important. Secondly, yes, sometimes I use my results and just saying in simple way that anxiety in Parkinson's disease is associated with changes in the brain, and Parkinson's disease enhance anxiety or the possibility to have anxiety because of lesions of the brain. But Parkinson's disease is not just all about dopamine and also other chemicals, other messengers. And we can use non-pharmacological treatment to modulate the brain. And sometimes I even say them that it's like a physiotherapist for the mind. You can modulate mind, and after that I refer to my CBT study saying that we saw that psychotherapy can modify things in the brain. But it's a really challenging thing, and even in France, because in France we have a lot of reimbursement. And some patients think that pharmacological treatments are the only solution. And
I'm going to interrupt you for a second because I want to ask you some other questions. Because you have convinced Mrs. Janssen, she's fine. But then her husband says, well, this all sounds great, but her brain doesn't work properly anymore. When we are together in a family meeting and we chat, she will respond to a question like 3 minutes later. So she's really slow. And then we do the Montreal cognitive assessment, and she scores 19 out of 30. So that's going to be a problem. You have excluded patients with cognitive impairment from the CBT trial. If you would have included them, how do you think that would have influenced your neuroimaging results? So not the CBT part, but just the results on the pathophysiology.
It would have been more difficult to just focus on anxiety, because probably some of the other brain regions, for example, prefrontal cortex and even basal ganglia, would have been impaired by cognitive impairments. It would have been possible with adjustments with cognitive disorders, for example, but I think it would have lead to a lack of power, of statistical power, maybe, because we will have to put some covariables adjustments. And finally, it would have been difficult to just conclude on anxiety pathophysiology and what is about anxiety and what is about cognitive impairments. But I think it's interesting, and maybe it's something that I can implement in the longitudinal studies we will work on to see how anxiety progress with cognitive scores, for example.
Can I ask one more question?
Unfortunately not.
Thank you.
We still have 2 more points.
Yeah.
Thank you very much. The opposition now will be continued by Professor Bakkers. I also would like to thank him that he is my secretary today, and he's involved in professor in clinical physics, in particularly neuroimaging at our university. I'd like to give him the word.
Thank you, Mr. Prorector. The candidate, also from me, my sincere congratulations. I mean, the supervision team has been mentioned, but I think you should also congratulate all the people, I think the first row that supported you in this trajectory. Your work is on the imaging of anxiety and fear brain secrets in patients with Parkinson's disease, and for that you performed multiple fMRI studies. My first question is more general on the use of functional MRI. You assess the brain with a block oxygen sensitive technique while the brain is in a resting state. I read you are or want to be a medical professional, and as far as I know, that every function of any organ in the clinic, it's assessed in a stimulated or an activated way, but not the brain. I mean, is that really the best way to assess the brain?
Highly esteemed opponent, thank you. It's a really interesting and challenging question. So the question is it a good way to analyze brain at a resting state? It is a validated way, but you're right, using also task can be also done in functional MRI. And maybe resting state is not the best word, because you're right also, our brain are never really in resting state. So is it the best way to evaluate the brain functions? Maybe not the best way, but is it one way? Because we can imagine the brain as an activated organ with different activations, with different actions or tasks. But even at rest, we have an activity. And when we say resting state, I mean it's more a physical thing, resting state of the body, than resting state of the brain. And even when we are in a resting state condition, your brain can also be activated. And it's a way, yes, it's a way to analyze brain functions, but it's not the only one.
Thank you. I mean, we're a little bit behind of time. I'd like to go to my next one, and that's on chapter 2, figure 2. Maybe your partner can help you with that. And you showed this very intriguing figure. It's about the upper panel. If I understood this correctly, it resembles a three-dimensional shape or the shape differences of the amygdala. And, well, the amygdala is an almond, that's how we say it, so it's a nut. But it's not a uniform structure as a nut, but it entails a collection of nuclei. And I'm standing in today for a neurologist, and she said, well, they're doing that in the wrong way. I mean, you should look at it as a plate filled with fruits. Then I thought about it. No, it's not a plate with fruits. It's a bag with goodies, multiple nuclei with different functions. And then I came in, and no, it's not a bag. It's, forgive me, Mr. Prorector, it's a panty filled with fruits. Mm-hmm. They're bulging out in that figure. And I think the arrows, correct me when I'm wrong, but the arrows represent the spatial direction of the shape differences, right? Okay. Now, this is described in terms of mathematical functions, spherical harmonics. By the way, it's very appropriate today. This is actually a French invention by a French mathematician, Pierre-Simon Laplace, around 1800. But let's go back to the nut. I mean, the 3D positions where these nut parts are bulging out in the panty, swelling, it must be one or more of the nuclei inside. And mathematically, your eyes are very sensitive to various spatial harmonics, also actually for many other body parts. But now my question, what about the known directions and the observation of the bulging out of the amygdala complex in this upper panel? And can you tell me from the protrusions which nucleus is bulging out?
Could you rephrase, please? I'm not sure to understand the question.
I mean, when you look at the upper panel, it's a bag filled with nuclei.
Yes.
And they are bulging out. That's where the arrows are pointing to the outward direction. And it must be one or more of the nuclei that is bigger than in a normal situation.
I'm not sure to understand, excuse me, but you mean that, yes, you mean that this shape analysis, right, have to be seen also with subnuclei inside of the amygdala? Yes, okay, thank you. Yes, it was also a possibility to do this kind of analysis with subnuclei of amygdala. But at this time, with 3 Tesla MRI, I have not done this at this time, but it's something I plan to do.
Okay.
But
from a functional point of view, you said you had 3 nuclei, the lateral one, the basolateral one, and there is a central one. I mean, they're not all for the anxiety system.
No.
But which one should it be?
Just to choose one is difficult because you have one is more an input and one is more an output. So choosing just one subnuclei between these 3 nuclei is difficult. I think I cannot answer like this because they are also linked. Maybe the basolateral nuclei, but I'm really not sure.
Perhaps you could check its position.
Yes.
Whether it's ventral, more dorsal, or otherwise, and check where this bulging out, so this red spot is.
Oh, you mean in the?
Yeah.
Oh, yes.
Okay.
I think it was the more the basolateral part of the amygdala, but.
Yeah, that's a nucleus.
Yes, but it was difficult to put it in really 3 dimensions.
Okay. Thank you.
Thank you very much. So we continue to the last opponent, which is Professor De Fabre. He's the chair of the Department of Neurology at Lille University, and I also like to thank him that he joins today, and I give you the word.
Thank you, Mr. Prorector. Mr. Candidate, thank you for your work, your oral presentation, and also your engagement in our department the last years, both in clinical and teaching activities. I have a first question about the statement 4, especially on the cognitive behavioral therapy. We know, can we? Yeah, sure.
Cognitive behavioral therapy reduces anxiety and Parkinson's disease by increasing cognitive control of emotion within the limbic anxiety circuit. So this thesis, chapter 6.
Okay. And we know that we can propose this therapy to manage anxiety in PD. Don't you think that this therapy has some limits, especially if we take into account comorbidities, other non-motor symptoms, and also the different subtypes of anxiety, and also the intensity of anxiety?
Highly esteemed opponent, thank you for this question. I totally agree with you. There are a lot of limitations and using CBT, cognitive behavioral therapy, for those patients. But we have to work on these limitations in the future. As I said before, the first limitation is the accessibility. And when I say accessibility for patients, it also includes your different comments. So accessibility, when we take account the motor symptoms, the other non-motor symptoms, but also the cultural limitation of CBT for patients. So my answer is yes, there are a lot of limitations. And how can we go through these limitations? Maybe some studies work on tele-CBT, I mean using phone or internet. I also read something about virtual reality. And finally, maybe suggest something we can do at home, or sometimes in the hospital, sometimes at home, could be a way to limit this limitation. But
Okay.
we have to work on this.
Thank you. And my last question is about the statement 9.
In many cases, gardens and nature are more powerful than any medication. Dr. Oliver Sacks, everything is in its place.
Mr. Candidate, why do you choose this sentence for this statement?
Thank you. So yes, it's a personal statement, one of my last statements. And so I chose this sentence because it's a sentence from Dr. Oliver Sacks, which is a neurologist in New York, and he was also a noveler, reported experience about his neurology activity, clinical activity, but also about his own life. And I totally agree with him when we say that garden and nature can also be important and can also help people to feel better. I totally agree. And it's also one of my hobby. You know that one of my hobby is gardening and nature. And even when my fear circuit is overactivated and when I'm stressed or nervous, gardening and nature helps me to feel better. So that was important for me to state this sentence in my PhD thesis.
Okay, thank you. Thank you, Mr. Prorector.
Thank you very much. And then I give another opportunity, since we have some time left over, to Dr. Rutten, because I noticed she has one question left over. I'd like to give you the word.
Thank you so much. So I actually wanted to give the word to the son that came to the consultation. He is more of the hands-on type, and he says, well, I'm a doctor too. He's a surgeon. He did his internships of psychiatry, and I said, well, why don't we just give mom some electroconvulsive therapy to jot up the neurotransmitter systems, improve neuroplasticity? I'm sure it will work. You see her having a panic attack almost. What would your answer be?
I would say that ECT, sorry, can be dangerous if you use it too soon. And first of all, we have to figure out if there is depression, because it's used especially in depression, I guess, and not at firstly. So maybe we have to try something else. It can be safe for PD patients, and we already done this in Lille and worldwide, but I would say not now. Maybe too dangerous, not appropriate.
I guess you finished your answer. I think what this is was you finished perfectly. Then I would like to conclude. Mr. Candidate, Mr. Carey, the time appointed for defending your thesis has been passed. The degree committee now will withdraw to discuss not so much the quality of your thesis, that has already been approved, but we're going to discuss the way you have defended your thesis this morning. And I request that you and your company here present await the results of our deliberations and to return to the aula. Thank you very much.
All right, please.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Southside, 7 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. All your time, 'cause I'll go the extra mile. Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Take the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. Even though these nights seem long, I know that I am never on my own. Know you won the battle once you've grown. Southside, 10 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. Long road to the south side. 10 miles in my rearview mirror. I know what it felt like. my goals only getting clearer. East side to the west side, no place like home. If it's questions that you've got, go the extra mile and die. What's on the line? I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. 'Cause I'll go the extra mile.
Dear Mr. Carey, the degree committee here present has assessed the quality of your thesis and in particular the way you have defended your thesis this morning. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you officially the degree of doctor. Professor Leentjes is authorized upon you to confer upon you this academic distinctions in accordance with Dutch university customs, and therefore I invite your supervisor now to take the floor.
All rise, please.
Do you promise to work in accordance with the principles of scientific integrity at all times? To be careful and honest, transparent, independent, and responsible?
Yes, I promise.
Okay. By the authority vested in us by law and in the conformity with the decision of the committee here present, I hereby confer upon you, Guillaume Carey, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with a degree certificate signed by the rector, the secretary, and the other members of the committee, and affixed with the official seal of the university.
Yeah. I'd like to give the word to Professor Dujardin, who also going to hand over the official Euron certificate. Professor Dujardin.
Dear Guillaume, on behalf of Euron, the European Graduate School of Neuroscience, I am also entitled to hand you the official Euron certificate. Euron is a training network of 8 universities in the Netherlands, Belgium, Germany, France, and Luxembourg. This certificate is awarded to PhD graduates that have participated in multiple courses and conferences in the Euron program, that have collaborated and worked in a foreign research group, that have published their work in international scientific journals.
Then there will be a third degree. So now I give the word to Professor Linden as director of the School for Mental Health and Neuroscience to officially hand over the men's certificate. And you can take a picture again if you want. Move forward.
This is to confirm the men's certificate, Mental Health and Neuroscience Research Institute, and confirms that you as a candidate have received training in a broad range of scientific and academic skills that enable you to work as an independent scholar in the future. Thank you very much.
Thank you. Then I would like to give back the word to Professor Leentjes, who is going to speak the official laudatio to the candidate.
Thank you, Mr. Prorector. Dr. Carey, dear Guillaume, I just had the honor of being the first person to congratulate you, but I want to start with expanding my congratulations to Mathilde, to your parents and family. Guillaume, you have done a great job. You combined a work-intensive research with demanding medical training to become a neurologist and managed to complete both trainings within the allotted time. And what is more, you made it look like combining these two trajectories did not cost you any effort. As a researcher, you were always enthusiastic, conscientious, hardworking, and throughout your PhD trajectory, you always coined a lot of new ideas for further research, sometimes too many, which means we often had to restrain you and at times made you focus on the actual projects that you were working on, which were necessary to complete your thesis. And this resulted in 6 papers, all published in high-ranking international scientific journals, and with several more on the way. And over the past few years, you also held several poster and oral presentations at international meetings. In addition, you mentioned several other activities on the side, such as being the PhD representative for the Euro Network. We've just heard what the Euro Network is. And if that is not enough, you also managed to get married last year, so congratulations for that again. One other thing that characterizes you is the fact that you never let any setbacks discourage you from pursuing your aim. In 2019, when you came to work in Maastricht for the first time on a Euro Mobility grant, the COVID pandemic hit us and you had to leave abruptly just one day before the lockdown. But we continued collaborating online, working with remote access on our data and on our servers. And this collaboration led to the inscription for the doctorate in October 2020. And this was in fact the first joint doctorate between our 2 universities, built on a collaboration that goes back almost 20 years with Kati and the department. Another achievement that you are to be commended for is for not losing the motivation because of administrative adversities. And I'm glad to see that you beat the joint administrative bodies of our universities by completing your thesis before the umbrella agreement between the universities could be completed, which is quite an achievement, or maybe it wasn't. As said, you are the first double doctorate between our 2 universities and a very successful one. We are happy that we can extend our collaboration with you as postdoctoral researcher until you will start your work and tenure track at Reims University. And even after that, we hope to continue our collaboration with Lille as well as with Reims. And as part of your postdoctoral exchange, you are now working on a grant application for a new joint PhD, which we hope will be awarded. And if this is the case, maybe you can coin the idea of introducing Reims as the second Euron partner from France. Guillaume, I wish you very much success with your career, as well as a happy family life, and, comme on dit en français, bien fait mon ami.
Well, dear, I would say officially, Dr. Carey, it feels good, I suppose. I would also like to congratulate you on behalf of Maastricht University. You had a very nice presentation. You had difficult questions to address in the last 45 minutes, but you addressed them all well. So, and we came to a unanimous decision. In my congratulations, I also take the promotion team who guided you over the last 4 years. And I noticed you started November 2020. It was also at Corona time that you had to work here, and that's also a big compliment to you as well. In my congratulations also your family, your recent wife, as you mentioned, Matilda, and your parents, I suppose, over here, and I would like to welcome them. I also would like to thank the members of the Corona who joined us today, the 6 members. I know it takes only 7 minutes to ask questions, but it takes more time to prepare these 7 minutes, and I would like to thank them, and particularly the guests from Lille and the guests from Amsterdam who took the time to come over here. As a personal note, as past founding director of Euron, I'm very pleased that you get also now the Euron certificate. And I noticed that also the new director is here with the program coordinator in the audience, and it's really nice to see how it's flourishing. Very nice. By saying this, we're going to conclude. For the conclusion, I need my hammer. You haven't seen it, it's right here. And I close officially this session, and I just want to mention how to proceed with your Corona members here, your promotion team, and of course you and your partner. We're going to make a picture on the stairs of the university, but the guests who are here in the aula don't have to wait for that. You can already go to the rafter, which is the place where there is a reception, and we will join there in about 7 minutes. Thank you very much.